All right, continuing on our intro to calculus, we're going to be looking at the difference quotient, but now we're going to take something we've learned, the limit, and attaching it to it. Okay, so these are two different topics that we've actually talked about already, and we are going to be combining them to help us start with some calculus. So, first off, for those of you that forgot, this is the difference quotient. This is the difference quotient. So, f of h, or f of x plus h minus f of x all over h. Okay, so there's your difference quotient. That is your formula to do your difference quotient that we've talked about way at the beginning of the year. Okay, and so what you would do is you take your original function, you plug it in and solve this, and end up getting it. So if we have a problem like this and we want to start doing our difference quotient, what we do is that we replace every x with x plus h. Okay, so every x has been replaced with x plus h, and then we subtract the original. So we have 3 times x plus h squared plus 4 x plus h plus 6 minus, and then the original function, 3x squared plus 4x plus 6 all over h. And now we want to simplify. Okay, so since we want to simplify it, what we end up doing is that we end up taking this part and we square it, which it always ends up being x squared plus 2xh plus h squared. Okay, so it always ends up that, and then we're going to multiply that 3 into it. So it'd be 3x squared plus 6xh plus 3h squared. And then we distribute the next one, so we distribute this 4. And then what we want to do is we want to make sure that this negative gets distributed to every single one. And so as we simplify it down, so there it is multiplied out, and now we start simplifying, and what you'll notice is that the subtracting of the original function, all of those end up canceling. Okay, so all of those end up canceling, which it should, for the most part, always happen. Okay, and that's one thing that's nice about this function, is that those cancel out, leaving us with just 6xh plus 3h squared plus 4h all over h, and then we can reduce that h out, so that h on the bottom disappears. And then we're left with just 3x, or 6x, plus 3h, plus 4. And that ends up being our answer. Okay, so that was using the difference quotient. That's just a quick run through because we have done this already. And so this is just kind of a refresher for it. We did it several months back, but we are bringing it back with a vengeance for this one. Okay, so that's how we do our difference quotient. So now what we want to do is, let's say we do it with a simpler one. So that was more complicated because we already knew it, so now we're going to add something to it. So we have 3x plus 5. So let's do the difference quotient. So we're going to plug in that x plus h. So it's 3x plus h plus 5 minus 3x plus 5. So now we distribute this 3, and we distribute this negative, and we end up with 3x plus 3h plus 5 minus 3x minus 5, and again you notice that the original function disappears, and we're left with just 3h over 3 reduced gets us 3. Now, quick question. There's a connection between that top function and the number 3. So thinking about, what is that top function and the number 3? What's special about 3 if you were to graph that top function? And that would be that it's its slope. Okay, kind of cool that you found the slope, even though it's easy to find it. Okay, that's going to come in important later on. So now what we're going to do is that we are going to add a limit to this difference quotient. So our difference quotient, f of x plus h minus f of x all over h, we are going to add a we're going to add a limit so that h approaches 0. Okay, so we still use the difference quotient as the same, but when we get down to the bottom, we end up plugging a 0 in for h. Okay, because we want to know what happens as h approaches 0. And what's happening here is that if h approaches 0, that means, if you remember kind of how we were doing the difference quotient, what the difference quotient would do would be taking and finding the slope between 2 points. So it's finding the slope between here and here. This distance is h. Okay, and it's basically finding what's the slope between those 2 points as a distance of h. When we take the limit as it approaches 0 of h, what ends up happening is that we are making this segment so small that they're basically on top of each other. and we're going to end up finding a tangent line of whatever it is that we're making. Okay, so we're taking that distance between our 2 points that we're finding the slope, because the slope you need 2 points. You need x1, y1, x2, y2. We're taking that distance between them, and instead of having it set at like 2 units, we're setting it at basically no units. So the distance between it's 0, and we do it that way. So here's that one equation that we had at the beginning. So we used the difference quotient, and we ended up with this. We ended up with 6x plus 3h plus 4. And that was our difference quotient. We did this, that was like the first slide. Now, what we're going to do here is that we're going to attach a limit as h approaches 0 of this function. So when we plug if h approaches 0, what we're going to do is we're going to plug 0 into just the h's, not the x. The x isn't what's being plugged in this one, so just the h's. And when we plug it in, we end up with 6x plus 4. That is our answer. That is what we're looking for. So what we're looking for is to do a difference quotient and then take the limit of that difference quotient as h approaches 0. Okay. All right, so now let's look at this one. So take a second and find the difference quotient of 4x squared minus 8. All right, so hopefully you found the difference quotient of it, which ends up being 8x plus 4h. Okay, so 8x plus 4h ends up being the difference quotient. Now we're going to take that, we're going to apply the limit as h approaches 0. So if h approaches 0, what is our new answer? Answer ends up being just 8x. Okay, so 8x ends up being our answer in this case. And that is our solution that we're looking for. Okay, so we're doing a difference quotient, and then we're applying a limit to it. Okay. All right, so that's the end of this section. Okay, so you basically just do a limit, or you do a difference quotient, then you apply a limit as h approaches 0 at the end of it.